When standard large language models attempt to process highly contradictory data streams at scale, their internal reasoning architecture mathematically collapses. Standard autoregressive models are built on next token prediction algorithms. They navigate their latent space by relying on linguistic probability, guessing the most likely subsequent word based on pre-training weights, rather than computing structural, causal logic. Because of this probabilistic design, when a model encounters a complex multi-hop contradiction across different domains, its attention mechanism tries to satisfy the dominant statistical weights. It mathematically averages out the conflicting inputs into a bivalent mean. We classify this failure mechanism as semantic saponification. As context windows grow to 128,000 tokens and beyond, this saponification effect becomes systemic. Rigorous, precise logic from entirely disparate epistemic regimes is continuously washed out, diluted into generic colloquial approximations. Here is the quantitative impact of semantic saponification across regimes. Testing a cross-domain mapping between YAML AST validation and memory safety, the L2 norm entity density drops 52.1%. Simultaneously, the Jensen-Shannon distance converges toward zero, indicating massive feature entanglement. By treating contradiction as an error to be minimized and smoothed over, standard transformers actively destroy the structural data necessary for autonomous multi-hop reasoning. Contradiction is not an anomaly. In highly complex multi-agent environments, contradictory data acts as valuable structural geometry, describing the contours of a pluriversal reality where multiple true paradigms coexist. The current Euclidean embeddings used by major AI models force all knowledge into a single spatial map. They are mathematically incapable of capturing the nonlinear, orthogonal geometry required to hold conflicting worldviews simultaneously. When you force orthogonal logics into a Euclidean space, you trigger what we define as epistemic triviality collapse. This collapse occurs when adversarial or mutually exclusive facts are ingested. The model's contradiction regulators fail, saturating both the positive and negative attention channels simultaneously. Every piece of data becomes ambiguous. To maintain absolute epistemic separation between conflicting data streams, we need an architecture that operates independently of the model's pre-training biases, a system that functions as a deterministic cognitive operating layer. To achieve this without semantic drift, we must implement the Paraconsistent Twist-Structured Transformer, or PTST. This is the only architectural framework mathematically designed to compute with contradictions without collapsing into triviality. The standard computational model plots truth and falsity as inverse points on a single linear scalar dimension. If evidence for truth increases, evidence for falsity must decrease. The PTST replaces this scalar line with twist-valued embeddings. This diagram illustrates the shift into a direct product space. Instead of a one-dimensional sliding scale, the latent space is expanded. A single token now carries two independent vectors, one exclusively dedicated to mapping truth, and the other exclusively dedicated to mapping falsity. These dual vectors track independent evidence and remain computationally isolated. Operating in a direct product space, positive and negative evidence scale simultaneously. The system registers massive evidence for a truth and massive evidence for its direct contradiction, without the two mathematically canceling to zero. Decoupling truth from falsity at the geometrical level provides the mathematical substrate required for paraconsistent logic to survive deep within the model's residual stream. Next, we must address how concepts are physically mapped. Standard tokens represent abstract concepts as dimensionless points in space. When data is inherently vague, pointing to a precise dimensionless dot guarantees the model will hallucinate. To prevent this, the PTST utilizes RCC8 Mario topology, a spatial logic framework that replaces dimensionless points with measurable topological boundaries. This is the egg yolk topological model. It geometrically maps the exact limits of conceptual vagueness. The solid inner core, the yolk, represents the minimal guaranteed extension. This is the zone of absolute conceptual certainty, where the mathematical definition is undisputable. The semi-transparent outer boundary, the egg, represents the maximum semantic extension. It plots the exact parameters where the concept becomes vague, ambiguous, or highly contextual. By applying a spatial bind operator, the network evaluates overlapping regions. If two semantic regions register as completely disconnected, the operator automatically prunes them from the computational matrix, dropping irrelevant context blocks instantly. Bounding vagueness geometrically prevents latent gravity collapse. The model is mathematically stripped of its ability to confidently assert facts in ambiguous, semi-transparent regions, eliminating the mechanism that produces hallucinations. Standard dot product attention only measures similarity. If two concepts match, they are routed together. But paraconsistent reasoning requires a much wider vocabulary of interaction. To handle this, the PTST deploys dialectic self-attention. This mechanism can measure positive support, negative suppression, both states simultaneously, or neither. This diagram maps the physical shattering of the standard query, key, and value matrices. To process dialectic data, the architecture fragments them into 6 distinct matrices, positive and negative grids for each category. With 6 matrices, the system computes interaction crosstalk. It explicitly measures the alignment between a positive query matrix and a negative key matrix. This specific crosstalk functions as a suppression alignment. It measures exactly how much a valid dissenting opinion should restrict a positive assertion. Crucially, this mathematical suppression modulates the outgoing signal, but it never erases the underlying contradictory data from the latent space. This 6-matrix architecture allows the attention head to natively execute 4-valued Belknap-Dunn logic directly at the hardware level. By re-engineering the attention head to calculate support and suppression independently, the transformer can output a state of high-tension superposition without crashing the execution layer. Holding multiple contradictory truths simultaneously generates immense symbolic viscosity. The computational load of balancing orthogonal logics requires a strict pacing mechanism. We manage this viscosity through thalamic entropy gates, utilizing a mechanism called Koromoto phase locking. These gates function like biological brainwaves. They act as volatile oscillator states that strictly prohibit structural weight updates, Hebbian learning, from firing prematurely. The system holds the noisy, contradictory data in tension, waiting until macroscopic phase coherence is mathematically verified across the attention heads before locking the outcome into permanent memory. When the network is placed under severe dialectical stress, ingesting conflicting logics that simply cannot be mathematically reconciled into coherence, the architecture physically responds. It triggers a spontaneous pitchfork bifurcation, physically splitting the neural pathway into isolated computational banks. This spontaneous lateralization allows the network to host deeply orthogonal logics in parallel, non-interfering expert banks, rather than catastrophically overwriting them. Permitting true contradictions inside a network introduces a severe threat. A localized paradox could trigger a global logical explosion, polluting the entire residual stream. To defend against this, the architecture relies on the chunk and permeate filter, which serves as the internal epistemic firewall. Under this protocol, individual attention heads are designated as localized, strictly quarantined computational chunks. If malicious data poisoning or a severe hallucination induces a logical paradox within a single head, the chaos is physically contained to that specific local chunk. The system immediately activates a mathematical permeability relation filter to assess the anomaly. This filter ruthlessly evaluates the output of the compromised chunk against a set of safe, non-explosive priors. Because the paradoxical data violates the permeability rules, the filter entirely blocks the explosion from advancing up the global residual stream. Only stable, non-explosive synthesized logic is permitted to pass through the filter and integrate into the broader network. This quarantine mechanism functions as an autonomic immune system, securing the macro architecture from both adversarial attacks and localized paradoxes. Sustaining a pluriversal architecture with direct product spaces and 6-matrix attention heads exacts a heavy computational toll. To maintain infinite horizon logical loops without collapsing under context bloat, the PTSTs utilizes chronosemantic demand paging. The system implements a conditional information bottleneck. This acts as a computational value-added tax on predictable, low-entropy tokens, actively penalizing cognitive bloat during standard chain-of-thought generation. When internal entropy reaches a critical threshold, indicating the KV cache is saturated with noise, the system triggers a micropause for synaptic downscaling. This content-dependent eviction algorithm identifies and erases low-value, stale contextual data, preventing the proactive interference that causes models to lose track of long-horizon tasks. This level of thermodynamic optimization preserves the integrity of the model's working memory, allowing it to execute ultra-long-horizon reasoning with the precision of a newly instantiated session. When all of these mechanics are assembled, the twist-valued embeddings, the egg-yolk boundaries, the dialethic attention matrices, and the permeability filters, we produce the pluriversal substrate. This enables the system to simultaneously process disparate domains. It maps the deterministic math of plasma physics onto the behavioral dynamics of organizational sociology. The causal geometries of both domains are mapped bijectively. Their structural integrity is preserved flawlessly, without ever averaging the conflicting terminologies into a bivalent compromise. Autonomous AI requires a foundation in rigid mathematical topology. The system must be able to verify its own internal consistency through geometric constraints, rather than relying on the statistical likelihood of its next token. By treating contradiction as a feature of geometry rather than a failure of logic, we move from models that merely predict strings of text to systems that can maintain the integrity of multiple conflicting realities in a single, stable reasoning loop.